Okay, so for today, we're going to talk about how light is made. And this has applications ranging from the incandescent light bulb to something as extravagant as fireworks. So most people are familiar with the like popular view of what the atom looks like. And that's something like this. Pull this out of a textbook right here. This one. Okay, that's known as the Rutherford Model. That is the one that's on like Jimmy Neutron's t-shirt, etc. And that's the one that I'm going to be talking about in terms of here today. So you have your nucleus. The nucleus is surrounded by these rings, which we call orbitals or energy levels. And that's where the little electrons are found orbiting. Again, in that classic view or image that we have of the atom. So when light is made, what happens is one or more of the electrons are struck with some kind of energy. This energy can come from electricity, like if you have a light that's plugged into a wall. It can come from heat, like like from a flame, like from a fire. It can come from even something like electrostatic, like if you've ever moved just right under the covers in the winter and maybe seen a spark. That's the same thing. It's electrons that are jumping up in energy level from gathering energy from somewhere else. So once this energy comes in and hits a little electron, what it does is it jumps up to another orbital. Now it can be the next orbital, it can actually make its own new orbital, whatever the case may be, it jumps up. This is not stable, it only lasts for about a moment, and then that electron will fall back down to where it came from, and when it does that, it pops off a little bit of light energy in a little packet that's known as a photon. Now the cool thing about this is that every element, every single one on the periodic table would technically have its own unique spectrum that it gives off within this little photon or packet of energy. And different elements can exhibit different colors of light because of this. Whether they're ignited in like a glass tube, everybody knows the classic neon sign. A true neon sign is actually only filled with neon, and it only should be orange. We call every electric sign, whether it's green or blue, we tend to call it a neon sign. That's like a pop culture thing. But a true neon sign would only be orange. And every element gives off its own unique color. And I'm going to show you some of those today. Okay, so now for the cool part here. This demo is obviously a little bit tricky to do at home because I have access to a Bunsen burner, the chemicals that I need, and the safety goggles. But I promise it's going to be pretty cool. So what's called an ionic compound, which is when a metal atom bonds to a non-metal atom, we get what's called a salt. So these are metal salts. The two that I've chosen today are a copper salt and a lithium salt because they're going to give you pretty spectacular colors. And they're pretty often used in things like fireworks and for special effects in movies and whatnot. So the first one I'm going to do for you is the copper salt. Get a little bit on my popsicle stick here. Put that in the flame, and you can see it's a pretty red-green color, right? Again, I am using this heat energy to get those electrons nice and excited. And they jump up in orbital. When they fall back down, they give off this characteristic color that you're seeing here, this green. Pretty cool. The second one that I'm going to show you is a lithium salt, which, as you can see, has a pretty distinct fuchsia or dark pink color here, very bright. And again, I'm using this heat energy to excite those electrons that you see here. Now, table salt, sodium chloride, is a metal to a non-metal, and we do the same things. Table salt actually gives kind of a bright orangey yellow color, very, very bright. Those electrons get excited pretty easily, and so the flame, the different color, appears really quickly. I also like to do this too. I like to mix the two popsicle sticks together to get sort of a watermelon flame. Pretty cool. Thanks.